Hi, we're going to look at a problem where you are determining whether two ratios are equivalent, and you're going to use that to make comparisons. So I'm going to present to you a problem, and then I'm going to have you pause the video and try to solve the problem, and then turn it back on and see how you did. So I want you to imagine a dining room at a camp that has two sizes of tables. There's a large table, and then there is a smaller table. And so the large table fits 10 people and the smaller table fits 8 people. So they are serving these tables and they're having pizza one day. And so they place 4 pizzas at the large table and they put 3 pizzas at the small table. So the large table has more people and they have more pizza, and the small table has less people and they have less pizza. The question is, do you get the same amount of pizza no matter which table you choose? So, does a person sitting at the small table get the same amount of pizza as a person sitting at a large table? And what I need you to imagine for this problem is that you can't have any leftovers, and everyone at the table gets the exact same amount. So you have to share everything equally. So go ahead and try this problem. Remember, there are 10 people at the large table and 4 pizzas, 8 people at the small table and 3 pizzas, and see, do they get the same amount, or does one of the tables, do you get a chance of getting more pizza? Pause the video, write something down on paper, and then once you're ready, go ahead and resume the video. Okay, so to be able to compare these two tables, before when we were comparing juice, we found the percent concentrate, but you really can't find the percent pizza at the table because you can't take the people and the pizza and divide and think you're going to get a percent pizza or a percent people. That doesn't work that way because the labels don't work in that sense. So you have to devise a different strategy and figure out how to share this pizza. And one way to do that, one way to show your strategy, because you probably have an idea of what you think the answer is, but you want to make sure your numbers make sense. Because what we want to be careful is if we're just dividing. If we're just dividing these up, if all you did was divide, then you may or may not have gotten the right answer. So let's try it differently. Let's look at the tables. So here's the large table at the top and the small table at the bottom. So one strategy that makes the most sense for people is to divide up the pizzas into slices. And so if I take the pizza and divide up into 8 slices, which is the easiest way to cut pizza into 8 slices, then I would have a total of 32 slices of pizza at the large table, and we would have 24 slices at the small table. And if I take those 32 slices, so we would have 32 slices. If I take those 32 slices and divide them up by the 10 people, then each person would get 3 whole slices and 1/5 or 2/10 of a slice. But at the other table, if I take and slice into 8 slices, then that's a total of 24 slices divided by the 8 people, and so they would get 3 slices. There's no additional slice there. So that being said, you would get more pizza at the large table. Now, some of you may have also divided and thought, well, I divided this up and I got slices. But when I got slices, I had a different answer and I thought the small table got more. Well, let me show you something that people do that is a mistake and that you don't want to avoid. And that's that they take the people, the 10, and divide the people by the pizzas. And if you take people and divide them by pizzas, you would get 2.5. Well, that's not 2.5 slices. That's people. You've divided people. That's 2.5 people per pizza. So we don't want to divide people. We want to divide the pizza. So if that's a strategy you used, that